This GBVIMS video short is an overview of data visualization. Data visualization is often equated with visual communication. At its core, it's the creation and analysis of visual representations of data. This training will really be a primer to introduce concepts and tools for you to dig into deeper. If you're interested in learning more, you can research the tools we'll discuss, or you can visit techchange.org for courses that cover data visualization in more detail. Why should we focus on data visualization in the first place? What is it about our brains that makes good visualization a useful tool? And how do visualizations work to clearly communicate data? It's about seeing the patterns and connections that matter. Data visualization allows us to focus on what's important. David McCandless, a data journalist, says, with data visualization, you start to see different relationships to the numbers. You can literally see them, but more importantly, you start to see patterns and connections between numbers that would otherwise be scattered across multiple news reports. The purpose of data is to clarify ideas, transfer knowledge or insight, or extract meaning about the domain the data is drawn from. But raw data is hard for our human brains to understand, and exponentially more so as more and more data is added. The human eye is, however, exceptionally good at scanning to find outliers and abnormalities and recognizing repetition and other types of patterns. So when we abstract the data to produce a visual representation of it, our brain is finely tuned to create a model of the data being communicated. In this way, we can come to an understanding of the underlying data, or often only a sample or projection of it, in much less time and with much less effort than it would take to read the raw data. Let's talk about a well-documented example of why data visualization matters. In 1854, in London, there was an epidemic of cholera. The belief at the time was that the disease was caused by bad air, but a doctor named John Snow was skeptical of this explanation. He had a theory. To investigate his theory, he mapped all cases in one area of the city to show that the outbreak centered on those neighborhoods drawing from one particular water pump. He used this image to convince the local authorities to disable the water pump, which greatly reduced the number of infections in the area. Digging further into that question of why we should visualize data, let's talk about how our brains are wired for this. The human eye has evolved to very quickly spot outliers and unique elements. We can do this in about 200 to 250 milliseconds with very little effort or cognitive load. If you design your visualizations so the eye is drawn to the most important points, and to keep clutter and chart junk to a minimum, your viewers will immediately understand the key features without any time or effort wasted. Our brains are wired to be pattern-making machines. Because of that, when putting together your visualization, it's important to question these connections. Do you think the two data sets are related, or do you know? What data or research exists to prove it? This is where thinking like a journalist becomes handy. Journalists have to make sure that they are only presenting what they know and can verify to be true, or else they get into a lot of trouble. As someone presenting data to the world, you hold the same responsibility. With great power comes great responsibility, and you have that responsibility as someone who is presenting information that may be actionable. But there's one more way thinking like a journalist can make your life easier. It helps you focus your visualization on the facts, the who, what, where, when, why, and how. Here are some questions to get you started. Who is your viewer? What types of decisions does your viewer make? What information do they need? And how will your data visualization add value? What's your viewer's digital literacy? And what's your viewer's prior experience with data visualization? Answering these questions can be incredibly helpful and powerful for you to be able to visualize, if we're talking about the GBVIMS, the impact of violence, the scale of violence reported, the survivor or alleged perpetrator profiles, where the violence is occurring. These are just a few examples of data points worthy to visualize in the GBVIMS. Next, let's talk about information design. Design is incredibly flexible, but there are some generally accepted rules. I'll introduce these briefly, and then you can Google to learn more. One of them is called Tufts rules. Some of Tufts rules are show your data, meaning data design cannot be complete without the actual data. Next, use graphics. It's best to use pictures and graphics when words alone cannot communicate your message effectively. Then, avoid chart junk. Chart junk is what happens when your data design focuses too much on the design aspect. Then, utilize data ink. So above all else, your data is the priority. You should only include design elements that will help your data be understood more effectively. Next, use labels. Labels are informative guides and are essential in data design. To label effectively, focus on clarity, readability, and differentiation. The label should stand out from the data. And finally, utilize color. Use this wisely, and above all, do no harm. Then we have the Gestalt principles for data visualization. Here, we're looking to group by similarity, proximity, and using enclosure or lines to show like objects. And finally, junk charts trifecta that you see here on the screen. This is a general framework for critiquing data visualization. It's asking 3 questions that overlap with each other. What is the question? What does the data say? And what does the visual say? This is a clear, quick way to evaluate your own visualizations. Data visualization encompasses a wide range of graphical displays, including static data visualizations. These are usually called charts. They're 2-dimensional representations of data we're all familiar with. Think Microsoft Excel or Google Sheets. These are great for producing these simple static visualizations. Then we have interactive data visualizations. This is where users can play with the visualization on a computer to make connections and explore data points. Dataseed or Tableau are an example of interactive data visualization tools. Then we have infographics. These are static graphic pieces that use a combination of charts and text to tell a particular story. Pictochart is just one of many tools you can use to create infographics. And finally, geographic maps, or graphical displays of the Earth, usually with a data overlay. CARTO and Leaflet are popular software packages for geographic mapping. If you're struggling with what type of chart to use, this is a simple guide to choose a chart type. You can think about your data in terms of, is this a comparison? Is this looking at distribution? Is it looking at composition or relationship? And from there, dig in deeper about what kind of chart will most effectively show your data. There's a lot written about the design process with a lot of different opinions. There are, however, some key shared components or phases. First, when you're looking at your data visualization, you should have an information gathering and research phase, where you learn as much as possible about the subject area and the data you have about it. Next, you should have an empathy building or user experience research phase, where the goal is really to try to get inside the head of the user or the viewer so that you can best design a solution for them. Then, brainstorming, where you and your team get together and think about different ideas for how to solve the problem. Then, repeating a cycle of prototyping, feedback, testing, and iteration, where you create a quick, incomplete versions of your idea, get feedback from your team and users, and then work to continually refine and improve the idea. And finally, testing and execution, where you have a user or independent third party test the work before releasing it in its final form. This design process applies to a lot of different aspects of design, but certainly also to data visualization. You can go through this process of gathering expertise, looking at it from a user experience perspective, revising, reframing, exploring it through a prototype, and then finally putting it out into the world. Of all the design phases out there, one of the most well-renowned methods and possibly most used comes from IDEO, an international design firm, and this is their visual that's on the screen. For them, the process is not linear. It has loops back to previous steps and a lot of refinement. For them, it's important to resist the urge to lock down ideas before you understand your subject matter and audience. Trying to make your data fit into an unrelated narrative won't work. You have to start with the data and work outward from there. So now we know why data visualization matters. What are some basic guiding rules, and what are some types of visualization? Now we want to talk about what makes a good data visualization. So some elements you might consider are metaphor, storytelling, using color effectively, and feedback. First, let's talk about metaphor. In David McCandless's TED Talk, What Makes a Good Data Visualization, one of the core principles is visual form, metaphor. But what does metaphor have to do with visual designs? We often think of metaphor as something used in language, creating phrases like silence is golden, where silence is not literally gold nor any color, but connecting it in a way that implies that silence has a strong value, like gold does. Metaphor can also be used visually, illustrating what the data represents to draw a metaphorical connection. And I'll come back to this metaphor option with a few more examples later on. Second, storytelling. Why do stories and data go together? If showing data visually helps readers to more easily understand what the data is saying, story becomes the framework that makes the data relatable. Third, color intentionality. Color is one of the most powerful tools in the data designer's tool belt. It's also one of the most complicated. The visual here on the screen is from the famous New York Times survey on how you talk. You can see quickly from looking at this visual what it means just looking at the color bar at the top. You can see where it's most similar and least similar very quickly with little cognitive load. Finally, feedback. Here are some guidelines you can use to help you get the best feedback you can. First, get feedback as early as possible in the process. You can accomplish this by holding regular design check-ins where your team and stakeholders can offer their thoughts early and often. Next, ask the right questions. This is one of those things that just takes some practice. The goal is to move away from subjective questions like, what do you think and do you like it? And instead to ask questions like, does this convey our message accurately? Does it represent our data as clearly as it can? What suggestions do you have to make it better to meet our goals? And finally, consider your audience. Your boss likely doesn't want to sit through meetings talking about all the nitty-gritty details, and your developer may not be well suited to give critical design advice. Consider who you're talking to, and this will help you ask better questions. Now we'll go briefly through several tools you can consider to aid in data visualization. The first one is INFOGR.AM, or INFOGR.AM. That's their website. This is a tool to make charts. They have over 35 different charts you can customize and over 500 different maps. They have ready-made chart designs that you can click in and update the data to your dataset. You can easily edit your content and customize it to your audience. You can even make animated GIFs to import them into HTML or embed them and make them interactive on your website. Overall, this is a great tool to do more with your charts than you can do with a program like Excel. They make it easy for first-time users to work with, and you can start using it for free. This tool and others we'll be going over can be used with the GBVIMS incident recorder data for organizational analysis. Compiled or aggregate information can also be transformed into different visuals through these tools. Next is CANVA and NOUN project. CANVA is really data visualization's best friend. This is like the ultimate template goldmine. They have templates for design, for social media, for infographics, for letters, for blogs, for presentations. Their templates are incredibly easy to use. You just drag in or drag out elements, change the colors, fonts, images, anything. And you can do a lot with the free version. You can also work on it with a team of users. NOUN project is data visualization's other best friend. This is a great site to get icons and images you can download and use in Canva or PowerPoint or many other forums. The icons are unique and modern and cover a wide range of topics. This should absolutely be a bookmarked site for you. Next, there are geographic maps. There are a lot of tools for the range of spatial analyses you can do with data. QGIS is an open source geographic information system software that enables the user to dive deep into typical and advanced geospatial analyses. CARTO has spatial analysis tools that are focused to be used by a broader audience of non-coders and mapping beginners. They are well known and they have a decent user-driven interface both in the design and in analysis. Again, thinking about the cholera example from the beginning, this type of analysis can be incredibly impactful for viewers. The next one is TABLEAU. This is a visual analytics software that allows users to create several types of data visualizations and share those visuals with team members and stakeholders. They also have a mobile-specific platform that works for Android, iPad, and mobile browsers. You have access to a lot of dashboards to change and revise your data, and you can also make the data interactive and share it online. The advantage is that it's really incredibly user-friendly. The disadvantage is the cost. They do have free trials on the website and training videos if you want to learn more before you invest in this type of tool. The next one is Power BI. This is a tool from Microsoft. It's also a visual analytics software. It builds interactive tools like TABLEAU does. The advantage with this one is that it's also easy to use, and they have a free desktop version. The drawback is that it doesn't have quite all of the features you might need in the free package. Tableau is a slightly more robust product with more reporting options, but this tool can do a lot with very little investment. Finally, Excel. We at the GBVIMS are not ones to discount the power of Excel. There's a lot you can do with Excel and data visualization, so don't just easily ignore this. A few very quick tips. First, be really thoughtful about the formulas you use and use them to your advantage. VLOOKUP allows you to identify the value in any column to the right of the first column simply by providing Excel with the value in the first column and the corresponding range of data. Index match is unique from VLOOKUP because VLOOKUP can only identify values to the right of the known corresponding value. So VLOOKUP is most useful when you have a large data set in which a value is in the first column is the known value. Whereas index match allows you to identify a value by providing Excel with a known value to the right or the left of it. Using index match to identify data is handy when you have a very large data set, and manually identifying corresponding data would be an onerous process. Another one is COUNTIF. This is another statistical function in Excel to count the number of cells that meet a criterion. For example, to count the number of times a particular location appears in a list. This is a quick way to get a summary number. Outside of formulas, you could also look at other options for visualization in Excel. The visual here on the screen shows several options for how to show your data. Spark lines, dot plots, slicers. These are less commonly used ones that you might consider using. And finally, when you're visualizing in Excel, don't forget your principles. Show the data, reduce the clutter, integrate text. As we wrap up, I also want to encourage some things that you could do to advance your data visualization skills that are a little bit outside the box. First, a good practice is to figure out who exactly is your audience for this visualization. You can even create an audience persona, like a profile of an audience member. Create a fictitious version of the person you are gearing your visualization towards. What is their background, existing knowledge of the topic, digital literacy, time availability? And if you want to look at a template, you can check out Extensio for ideas. Second, drawing it out. Go analog, draw your visualization, sketch your ideas for data visualization before immediately jumping in to one of these admittedly cool tools for digital visualization. And if you're really invested in thinking outside the box and sketching before you go digital, you can embark on a Dear Data-based conversation involving creating data visualizations of your daily habits in life. You can Google Dear Data to see the full project. This project was 2 women who visualized aspects of their life for a year and sent it to each other on a postcard once a week. The visual on this slide shows one I did tracking smiles that week. Again, going back to the metaphor example. Because smiling is contagious, here I visualized it like bacteria. This is just one way we can expand our thinking and creativity when it comes to visualization. So that's it for this video short. If you'd like to learn more, I really can't highly recommend enough Tech Change. They have a specific course that goes over everything we went over in this course called Technology for Data Visualization Analysis. The content of this video short is greatly pulled from that training and reduced from a 4-week training into about a 20-minute video short. So really, if you want to learn more, go to Tech Change there. A big thanks to Tech Change. As always, be responsible with your data and learn more at GBVIMS.com. And in the case of this video short, also visit techchange.org for great remote learning opportunities.